Welcome to the educational research section of www.happynumbers.com. Today's video is going to introduce what are called single case research designs, and a very specific one, one called an AB or an ABA or an ABAB withdrawal design. But just a brief introduction about single case designs. Single case designs came out of the fields of biology and psychology, and they were used, and we use them in special education a great deal. And they're used when we can't get a large group, a large sample together so that we can have it controlled in an experimental group. And so a series of what are called single case designs have been developed. And single case doesn't mean that there is just one participant. It means there's one case. Now, a case could be a classroom, or a case could be a group of 5 students or something like that, or it could be one student, depends. But there is single case designs can establish good internal validity and experimental control without having to have a experimental group and a control group and random assignment. And so the designs were developed for that specific reason, for cases where we cannot have a large sample to draw from. So we're going to take a look at what is called the AB or ABA or ABAB withdrawal designs. And we're going to go over some vocabulary, so I would encourage you, you may want to take some notes initially, because this vocabulary will remain the same for all the different single case designs that we go over. Well, let's take a look at an AB design. Okay, let's just take a look at this graph here. Along the bottom, let's say we have a classroom, and we're going to, up here, the effects of positive reinforcement on the number of inappropriate shouts or call-outs. So let's say we have a student who engages during class in inappropriate shouts and call-outs. And we want to test the effectiveness of positive reinforcement on reducing those. So we have a graph here, and across the bottom is the number of sessions. So let's say these are the days that we're observing this student, number of sessions, and the y-axis is the number of call-outs, And you can see we've observed for 4 days, and we have like 14, 15 call-outs in those 4 days. So that's what this graph represents. Now, this initial 4 data points, or the 4 days that we were collecting data, is called a baseline condition, or the A condition. Now, I don't know why they call it A when baseline begins with B, but that's just the way it is. So this is the A condition, or the baseline condition. Now, a couple of terms here that we need to know about. Baseline stability in terms of level and trend. Baseline stability in terms of level and trend. This data, the first 4 data points here, are pretty stable in terms of level, because they're all around 14, and in terms of their trend, so the trend is almost like a straight line. So in terms of level and trend, they are very stable. When working with an AB design, when the baseline data is stable, a concept called baseline logic kicks in. And baseline logic states that if behavioral data, if you're collecting the data, and the data stabilizes in terms of its level and in terms of its trend, then we assume that the behavior has reached a natural level in the environment, and if no intervention is put into place, the behavior level and trend will remain the same. That's called baseline logic. So what we can assume here, since the data has stabilized in the baseline condition, or the A condition, in terms of level and trend, that if no intervention takes place, that this student's inappropriate call-outs and shouts will remain just about that same because it's reached its natural level in the environment. Well, now we introduce the positive reinforcement condition, and that is the intervention, positive reinforcement, and that is called the B condition. The B condition. A condition is baseline, B condition is intervention. So we can see, now of course I've just made this data up, we can see as we introduced positive reinforcement, the number of inappropriate call-outs drops in a therapeutic direction, drops down, getting close to zero. Well, what can we say about that data? Well, in terms of being a teacher, that data is fantastic. That's exactly what we wanted. That's absolutely what we wanted. But in terms of a researcher, it does not establish experimental control. We cannot say with any degree of confidence that it was the positive reinforcement that has caused the change in the dependent variable, the inappropriate number of call-outs or shouts, because there could have been many other explanations why the student stopped calling out. The student may be sick, may have a sore throat, could be a million explanations. So this is an A-B design, an A-B design. It's a pre-experimental design, and it really doesn't tell us anything in terms of internal validity or experimental control. However, it's great for the teacher, but for the researcher, it's very inadequate. Well, we can then add another baseline condition, or we can withdraw the positive reinforcement. That's why it's referred to as a withdrawal design. And now we have a second baseline condition. We go back to just the normal baseline condition. And we've noticed that the data has moved in a contratherapeutic direction and has gone back up to about the same level and trend as it did in the initial baseline condition. This, if the data in reality looked like this, we could make a pretty good case for internal validity, because we had our baseline data stabilized, we intervened and the data moved in a therapeutic direction, we withdrew the positive reinforcement intervention and the data moved in a contratherapeutic direction, and it stabilized in terms of level and trend at about the baseline level. So that makes a fairly strong case for experimental control. We can say with a pretty good degree of probability that it is the intervention, the independent variable, the positive reinforcement, that has caused the change in the dependent variable, the inappropriate call-outs and shouts. And researchers could stop here and could make a pretty good case for internal validity. However, there is an ethical problem here. How ethical is it to leave a participant in a non-therapeutic state? In other words, in an environment that is non-therapeutic, just because we wanted to see if this positive reinforcement would work. So we put in the second B condition. So that's why it's called an A-B withdrawal design. And we reinstitute the intervention, positive reinforcement. The data moves in a therapeutic direction and it stabilizes in level and trend at about the level that it was in the first intervention. Now we have a very, very strong case for internal validity. A very strong case. Okay, let's go back. I'm going to quickly review this again. Okay, so we're starting. This is an A condition baseline. We're looking at the number of sessions and inappropriate call-outs and shouts. We take baseline data. The baseline data has stabilized in terms of its level and trend, and so then baseline logic kicks in. Baseline logic states, if we do, the behavior has stabilized, therefore it's reached its natural level in the environment. If we do nothing, the behavior is going to stay at the same level where it is. Then we introduce positive reinforcement as the intervention, and the data moves in a therapeutic direction and it comes down. so that we're almost at 2 or 3 inappropriate callouts as opposed to 14 or 15. This is wonderful for a teacher, but a researcher, it does not establish experimental control, or it has no internal validity. So then we introduce the baseline condition again. We withdraw the positive reinforcement. If the data goes back up and to the same, approximately the same level and trend as it was in baseline, as it does here, then we have a fairly good case for internal validity. And we don't want to leave a participant in a non-therapeutic state, so we introduce the intervention again. If the data then moves in level and trend in the intervention 2 phase back to the level as it was in intervention 1 phase, we can say with a high degree of probability that it was the intervention, the independent variable, the positive reinforcement that has caused the change in the dependent variable, inappropriate callouts and shouts. So that is the ABAB design. Actually, it's a good example of an AB design, an ABA design, and then this one, the final one, the ABAB. Now, let's take a look at this one. This is the baseline condition. Notice here that this baseline data is not stable at all. It's all over the place. So, the researcher should not have intervened and carried out the experiment. This data, even though it looks like it moves in a therapeutic direction and then goes back up and then comes back down in a therapeutic direction, even so, since there was no baseline stability in the initial baseline condition, this particular data, the way it looks here, would have poor internal validity because baseline logic was not valid. The baseline data did not stabilize. So this is sort of a non-example. Okay, so quickly, the ABAB design advantages: very easy to use, simple data collection and analysis procedures are very easy to analyze. I mean, usually just a visual display of data for the analysis. Very suitable for classroom use. You can establish strong internal validity or demonstrate that the intervention is most probably the cause of the behavior change or experimental control. A major disadvantage of this is it's not well suited for behaviors that do not reverse. In other words, if you're teaching sight words using this, well, if students learn sight words, they're not going to unlearn them when you withdraw the intervention. So it doesn't work well for behaviors that will not reverse. But for behaviors that will reverse, it works very, very well. Okay, let's take a look at this, some vocabulary. Baseline condition 1, that's the initial baseline condition, and of course it's called the A condition. Intervention, that's the independent variable. Baseline condition 2, that's when you withdraw the intervention and go back to baseline. The concept of stability of data in terms of slope and trend and level. Oh, and by the way, there's usually a question of, well, how many data points do you need in the baseline condition to have the data be stabilized? Is 4 enough? Is 3 enough? Do you need 10? Isn't it better if you have 20 data points that are stabilized? Well, yes, it would be. However, there becomes an ethical consideration to keep a person in an extended baseline. So it has become accepted in single case designs that 3 or 4 relatively stable data points in terms of level and trend is enough, and then you can intervene. The concept of baseline logic, which means that if the data has stabilized in terms of level and trend, that it has reached its natural level in the environment, and if there is no intervention, it probably will not change. Internal validity, that's the degree to which we can say that the independent variable or the intervention has caused the change in the dependent variable. And external validity, pardon me, no one single case research study in and of itself has external validity. In other words, we cannot generalize based on one study. However, if there are repeated replications and a preponderance of evidence builds, then we can start to make a case for external validity. Well, here's a little assignment for those of you that are working with me. Outline 2 classroom scenarios where you might use an ABAB design, just roughly outline. What would be your intervention or your independent variable? What would you collect data on, your dependent variable? And then draw a graph using hypothetical data that represents one of your ABAB research design that indicates strong internal validity. And then briefly explain why it represents strong internal validity. Well, that's it for the AB series of designs. Thank you very much, and we'll see you next time.